Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
All right, question 11 in our book states that a beam of nuclei is used for cancer therapy. Each nucleus has an energy of 130 MeV. So from context, we know that's 130 MeV per nuclei, which I put here is MeV per n, nuclei events number, whichever you choose. And the RBE of this type of radiation is 16. The beam is directed onto a 0.17 kilogram mass or tumor, which receives a BED of 180 rem. How many nuclei are in the beam? So here's what's given to us. So we want to find the value for n. So here, based on what we've been given, we can find that. So if we want a relationship for n, first thing we should note is that one thing we are given is energy per number of events. So if you want number of nuclei in our numerator, then our Q over N term needs to be in our denominator. And simply by doing that, we can just convert multiply this by Q, where Q would be the total energy. So based on what's given to us in terms of RBE, BED, and mass, we can solve for this absorbed dose. Obviously, energy is just the mass times the absorbed dose. Carry that through. We know M, we know Q over N. So I'm going to pull those terms out in front, just so I have a little more room to work with an equation to solve for my dose here. So for the dose, we know the relationship between BED and RBE. It's simply just defined for dose, it's BED over RBE. And now looking what we have, we know mass, we know Q over N, we know BED, and we know RBE. So we have everything we need. If we need to convert units, which we almost always definitely will have to when we deal with these different types of radiations, we will do that when we notice what units we need. So I'm going to go on the second line up here. So my N value, my number of nuclei, is equal to 0.17 kilograms divided by 130 MeV per nuclei. Multiplying that by our BED of 180 rem divided by our RBE of 16. So we have units all over the place right now. I need my my energy term here, or I guess my dose in general, so this whole first term to be in rad, right? Because if I'm doing rem over RBE, that has units of, I guess I need to be 1 over rad in order for this to work. Because then remember, if we think of our equation from BED and RBE, BED equals RBE times dose. This term is unitless. This term, it has to be in rads. And their final BED is in rem as provided to us. So we need a dose in rad for this to work, which again, dose will be this term here because we have, actually this term goes like 1 over dose, right? So we need units of 1 over rad for that term. So the first thing we'll do, we have to get rid of MeV. So we need to go from MeV to joules, which gives us gray, and from gray to rad for our final answer. So as of right now, we have MeV in the denominator. So we need joules on our denominator. So we multiply this, or divide by this, I should say, is 1.6 times 10 to the negative 13 joules per MeV. Let's check our units at this point, just so we're 100% clear. Our MeVs cancel out. We have kilograms over joules, which is 1 over gray. Great, that's what we want. And now we gotta get rid of gray and put in rad. So again, that conversion, if we remember, gray is our denominator, so we multiply this by 1 gray, and then we must divide this by 100 rad as our conversion. And now we should be all set. Let's double check. We have J, joules, over kilograms on the inverse, multiply that by gray, and now we're left with 1 over rads, which is what we needed. Great. So we can simply multiply this through now, and we'd find that the number of nuclei is 9.2 times 10 to the 8, which I call capital N for nuclei. So there you go. So as for most of these problems, we get into a bit of a mess having to convert. So always check your units for energies and doses, and be sure you remember how to convert from MeV to joules to rads. There you go.